Well, so we are further continuing with the concept of oscillations and SHM, and some typical terms are to be explained in this. Like one of them is periodic time, the angular frequency, the damped force, resonant and maintained vibration. The forced, resonant and maintained vibrations. Well, so before starting with the main context, periodic time means the time taken by the particle to complete one vibration, or is the time taken to complete one oscillations. And angular frequency means that when particle is in SHM, how many times it is completing the vibration in 1 second. So angular frequency is represented by omega, and omega is given by function 2 pi n, or it is 2 pi over t. Periodic time means time taken to complete one vibration or time taken to complete one oscillation. And when we use the term damped vibrations, damped means, like for example, we consider a tuning fork. Tuning fork is allowed to vibrate in air medium, because it is communicating the longitudinal waves through the air medium. So air medium offers resistance. So when the vibrations are communicated by the tuning fork, we find that gradually the amplitude begins to drop and finally it is ceased. So damped oscillations are those in which in the earlier situation the amplitude is larger but gradually it vanishes. So such vibrations in which the vibrations vanish after some time, that is called damped vibration. Now sound waves are damped vibrations in air medium. Forced vibration means if we consider a set of the pendulums, suspended pendulums, and they're stationary, then one of the pendulum is allowed to displace. When it strikes the other pendulum bobs, we will find that vibrations are forcibly produced. So the vibrations produced in the stationary state of the pendulum bobs by displacing just one of the pendulum bob, those are called the forced vibrations. And when we use the term resonant vibrations, resonance is a phenomena in which two bodies vibrate in unison. Unison stands for same natural frequency. For example, if we consider two tuning forks and they are allowed to vibrate simultaneously, we find sometimes a loud sound is generated and sometimes a feeble sound is generated. So resonance, when we use the term, resonance is a phenomena in which two bodies vibrate in unison or with the same natural frequency. And when we use the term maintained vibrations, the body is vibrating, but it is losing some energy. So this energy loss is compensated by some external source. That external source supplies the energy to the body which is already vibrating, and the vibrations are maintained means that its frequency is maintained. So this is a general concept regarding the periodic motion, the angular frequency, the damped, the forced, resonant and maintained vibrations. So resonant vibrations are more rampant in case of the resonance apparatus, in which we consider a glass tube and some water is filled in it. So when we vibrate a tuning fork and put over the open end, we find that the vibrations, they move inside the tube. They are reflected back, and due to superposition of waves, the resultant wave is generated whose amplitude is more. So that is called a resonant vibration. And I have already explained the maintained vibration. That is, the energy loss takes place during the vibration, and that energy loss is compensated by some external source. So the formula for the periodic time will be T is equal to 1 over n. The angular frequency is omega, that is 2 pi n or 2 pi over t. And the remaining concepts, remaining terms which we are using, They are the physical concepts, so they are not in the form of formulas. Now we come towards methods to determine the periodic time, the angular frequency and frequency in SHM. And as I have earlier explained, the body is said to be executing SHM if its displacement is away from the mean position and the restoring forces towards the mean position, and frequency is directly proportional to displacement. Larger the displacement, larger will be the restoring force. Now this displacement can be vertical or horizontal. If it is horizontal displacement, we represent it by x, and if it is the vertical displacement, we represent it by y. So if the force is restoring force is F, which is caused by elasticity and inertia of the medium, then restoring force is proportional to X, that is the horizontal displacement, or F is proportional to Y, that is the vertical displacement. If we remove the proportionality sign, it will become F is equal to minus Kx or minus Ky. So now we are proceeding with the main text. If conditions of equilibrium are given, then equilibrium state of the system is determined. System is displaced by x distance from the equilibrium state. The equilibrium state means the mean position of the particle, and the particle which is executing SHM is known as harmonic oscillator. In displaced form, free body diagram is formed of the system. When we use the system, we are referring to any apparatus or any body which is maintaining SHM. Then it is the resultant force acting towards the equilibrium position is determined. Wherever we use this term equilibrium position, it is supposed to be the mean position, that is the starting point, and it can be proved by using equilibrium condition. Now we have come to the mathematical concept which I have just now spoken, that is F is proportional to X, where F is supposed to be the restoring force and X is the displacement. So F is equal to minus Kx, and negative sign indicate that force and displacement are opposite to each other, and K is supposed to be the that is spring constant or force constant. Now it is indicating the minus sign. So if we take the modulus of both sides, it will become F is equal to Kx, and from that we can get the value of acceleration, because force is equal to ma. F is equal to ma, and ma will be equal to minus Kx. A is equal to minus Kx by m, and K over m is omega square. So omega can be calculated as under root K by m, and omega can be written as 2 pi n or 2 pi over t. So we can change the equation, that is omega is K over m under root, or it can be n is equal to 1 by 2 pi under root K by m, and if we take the inverse function, that will become the time period. And if we take the derivative of displacement, it will become velocity. If we take the double derivative, it will become acceleration. So A is equal to minus omega square x. So this is the acceleration of the harmonic oscillator. And this is again indicating that acceleration and displacement are in opposite direction. That is what the significance of the negative sign. So we can say that is only taking the magnitude, it will become omega square is A over x, and then we take square root to find omega. And omega can be gradually transferred to 2 pi n and 2 pi by t, and from that we can get the value of n and t in terms of x and a.